Hi everyone, this is Easy Math. In this video, we are going to see class 8 mathematics exercise 1.5, which is in cubes and cube roots. We have done the first sum. First fill in the blanks, all the 5 we have done in the previous video. Now we'll see from second one, which is true or false. Okay. Now the first question is the cube of 24 ends with the digit 4. What is a cube? Let us recall what do you mean by cube. Cube is to the power 3. Multiplying a number 3 times. Multiplying the given number 3 times. So the cube of 24 means 24 into 24 into 24. Ends with the digit 4 means we have to find out only the ones place number. For that, you just multiply the only ones place number here, the ending digit. We have to find the ending digit. So let us multiply here also the ending digit. Ending digit is nothing but the ones place digit. And cube, so you multiply this 4 times. 4 into 4 into 4. If you multiply the ones digit, it is enough. We can find with what number 24 cube will end. Okay, now 4 4s are 16. Now, you just 6 into 4 you multiply. 6 4s are 24. So, what is the ending digit? Ones place digit is 4. Therefore, it is given 4. Therefore, the cube of 24 ends with 4 is true. Okay. This is how we find. You need not multiply 24 into 24 into 24. You just multiply the only ones place digit 3 times and check by what number it ends. We will get the correct answer. Okay, second one, subtracting 10 cube from 1729 gives 9 cube. Let us not bother about the answer. First, let us do this sum and check what answer we are getting. Okay, subtracting 10 cube. What is 10 cube? 10 into 10 into 10, that is 1000. We are subtracting 1000 from which number? Whatever number comes after the word from, that should be written first. So from 1729, subtract 10 cube, which is 1000. So when you subtract, we get 729. And what is this 729? It is nothing but 9 cube. You must be thorough with the square formula from 1 ones are 1 to 20 20s are 400. And cube formula from 1 into 1 into 1. 1 cube is 1, 2 cube is 8, 3 cube is 27. Like that you should know up to 10 into 10 into 10,000. Then all the answering these questions become very easy for you. So this 729 is nothing but 9 cube. You multiply 9 into 9 into 9. When you multiply 3 9s, you get 729. 9 9s are 81. 81 into 9 will give you 729. So 729 is nothing but 9 cube. So the second statement is also true. Next, the cube of 0.0012 is 0.00001728. You need not multiply and check. Before that, this is what is cube. You have to multiply this number 3 times. So after multiplying by 3 times, after the digit there are 3, after the point there are 4 digits. So when you multiply the same number 3 times, after multiplying, in one number there are 4 digits. So when you multiply 3 times, you will get 4 plus 4 plus 4, 12 digits. You have to count to 12 digits from one's place and keep the point. Now let us first count the digits if they are correct. If they are not, if they are right, we will check the multiplication. Otherwise, we need not check the multiplication. Without checking the multiplication, just by counting the digits itself, we can find out whether the cube is this number or not. So 4 after the point 4 digits. When you multiply this 3 times, after the point you should have 12 digits. One number 4 digits, and for 3 numbers 3 4s are 12 digits. Let us count 1, 2, 3, 4, 5, 6, 7, 8, 9 digits are only there. 5 zeros and 4. There are only 9 digits. But even though this 1728 is correct, there are only 9 digits, but after the point we should have 12 digits. So this answer is wrong. Okay, so it should have been along with this 9, you should have put 3 more zeros. Point, how many zeros? There are 4 digits means you should have 8 zeros and this number. Then only it is correct. But there are only 5 zeros, so it is wrong. Then 79570 is not a perfect cube. So this is also just by looking at the number we can find out, because if it is a perfect cube, if it ends with 0, then it should end with 3 zeros, 6 zeros, 9 zeros. It should end with the multiple of 3. The number of zeros should be multiple of 3. 3, 6, 9. A cube of a number cannot end with 1 0. See, 10 is not a perfect cube. Even 100 is not a perfect cube. But 1000 is a perfect cube because it ends with 3 0. And we can have 3 more zeros. This number also is a perfect cube because 6 zeros, it's a multiple of 3. Multiple of 3 means it comes in 3 tables. But ending with 1 0 is not a perfect cube. So this is also correct. Next, the cube root of 2,50,047. 2,50,047. 250047 is 63. What do you mean by cube root of this is this means when you multiply 63 into 63 into 63 3 times, when you multiply 63 you should get this answer. Cube root of this number is 63 means the reverse. Cube of 63 is this given number. So you multiply 63 into 63 into 63 and check whether you're getting this answer. So when you're multiplying, you will get this answer. So this is also true. Okay. Now let us go to the next one. Show that 1944 is not a perfect cube. So we cannot just be looking at the number, we cannot find. If it is ending with 0, we can see. If it ends with 3 0s, 6 zeros, we can guess whether it can be a perfect cube or not. But here we cannot guess. We have to do the sum and check whether it is a perfect cube or not. This is nothing but the prime factorization method, which we have done already. We will find the prime factors of the given number, and for every 3 factors, we have to select 1 factor. Okay, let us check it. We are following the same rules which we followed in prime factorization. Tell me, if it is an even number, divide by 2. If it is an even number, so let us recall the same steps. If the given number is an even number, then we divide by 2. If it is an odd number, we check by 3 tables. If it is not divisible, we check by 7, then by 11, then by 13. Check by the next, what numbers? Prime numbers we'll check. If it ends with 5 or 0, then we divide by 5. If you follow these rules, the division becomes very easy. Now, ending with 4 is an even number. So, we divide by 2. Come on, quickly divide by 2. Take 19 because 1 we cannot divide by 2. 19, 2 9s are 18. After 18, count till 19. That is a 1 reminder. What will you do? Carry with the next number 4. So, you get 14. Now 14 you divide by 2, 2 7s are 14. Do you have a reminder? 2 7s are 14. There is no reminder. So divide the next number, 2 2s are 4. Okay, it should be exactly divisible. At the end, you should not have any reminder. That is why we divide by the number by which it is divisible. The reminder should be 0. Now, what is 972? It is an even number. Ending with 2 is an even number. Divide by 2. Take the first number 9, 2 4s are 8. After 8, there is a reminder 1, 9. So 17, 2 8s are 16. After 16, 17, 1 reminder 12. 2 6s are 12. What is 486? Again even number, divide by 2. First number, 2 2s are 4, no reminder. 2 4s are 8, no reminder. Next 2 3s are 6. Now what is this 243? Ending with 3 is an odd number. So if it is an odd number, you check by 3 first. How to check whether this number is divisible by 3? Let us recall the divisibility rule. What is it? Just we will be adding all the digits. 2 plus 4 plus 3. 2 plus 4 is 6. 6 plus 3 is 9. Is this 9 comes in 3 tables? Add all the digits. That answer is there in 3 tables. That means this 243 we can divide by 3. So till 24. 3 8s are 24. Do you have a reminder? No. Next number, 3 1s are 3. 81, again ending with 1, odd number. Add them. 8 plus 1 is 9. 8 plus 1 is 9. Again, it is divisible by 3 tables. Okay, can we divide this by 9 tables? 9 9s are 81. Can we write 81 as 9 9s are 81? Even though it is divisible, we should not divide by 9 because 9 is not a prime number. The method itself is called prime factorization method. That means you should divide only by the prime numbers. 9 is not a prime number. Okay, that is why we divide by 3. That is a prime number. So 3 2s are 6. After 6, 7, 8. Carry with the next number 21. 3 7s are 21. 27 is so simple because the number is small. It is there in the tables itself. Divide by 3. 3 9s are 27. Now 9, again 3 3s are 9. What is this 3? It's a prime number. Once you get a prime number, we can stop the sum. Now let us check whether we can take one factor for every 3 factors. How many 2's we have? 2 into 2 into 2. We have 3 2's. 2 into 2 into 2. Then 1, 2, 3, 4, 5 3's. 3 into 3 into 3 into 3 into 3. If there is a cube root, then for every 3 factors, you have to select one factor. For these 3 2's, 1, 2. For these 3 3's, we can select 1, 3. But these two, only 2 3's. We should have 3 3's. Then only it is a perfect cube. But there are only 2 3's, one more 3 is missing. So we cannot select 1, 3 for this. We cannot group into 3 factors. Therefore, 1944 is not a. So when you take cube root of 1944, for 3 factors select one factor, but these 2 3 are left. There is no third 3. Therefore, it is not a perfect cube. Now we'll see question number 4. Find the smallest number by which 10,985 should be divided so that the quotient is a perfect cube. This is not a perfect cube. We want to make this number as a perfect cube. The method is same thing, just we'll do the prime factorization method and let us check what number is missing. Okay. So it is ending with 5. By what number will you divide? If a number ends with 0 or 5, divide by 5. So let us divide by 5. So when you divide by 5, 2 5s are 10, no remainder, 5 1s are 5. After 5, count till 9, 4 is the remainder. In 48, 5 9s are 45, remainder 3. In 35, 5 7s are 35. Now 2197 is an odd number ending with 7. So we should check by 3 tables, 7 tables, 11 and 13. If you go on checking by the numbers 3, 7, 11 and 13, you will find it is divisible by 13. It is not divisible by 3, 7 and 11. It is divisible only by 13. And when you divide by 13, you will get 169. Now 169 we know very well. It's a square number. We know the square tables from 1 to 20, isn't it? 13 13s are 169. And what is this 13? It's a prime number. You can stop the division. So now write all the factors 5 into 13 into 13 into 13. What is cube root? For every 3 same factors, we have to select one factor. For these 3 13s, we can take one 13. And the question is, what number it has to be divided? That means what is the extra number? This 5 should not be there for us. If 5 is not there, you check. For 3 13s, we can take 1 13 so that it becomes a perfect cube. Therefore, 10,985 must be divided by this extra factor 5. And when you divide by 5, when you divide by 5, you get 2197. And what is the cube root of 2197? We will get only 3 13s. For 3 13s, you can select 1 13. Understood?